All right, so this is something you've most likely learned before. So dilation means making something bigger or smaller, right? So I wanted you to, on your special warm-up sheet with grid paper on it, you're able to plot points on here, right? The grid. Okay. I wanted you to make a little cross like this, and then graph 1, 1, negative 1, negative 1, 2, negative 1. You should get this little triangle ABC, and then I wanted you to do what? Dilate, which means multiply all those x's and y's by 2. So let's do the math. 1 and 1. Multiply those by 2, and I get what? 2 comma 2. Right? All right, same thing with negative 1, negative 1. Multiply them both by 2. What do I get? Okay, negative 2, negative 2. Does that make sense? I'm just multiplying by 2. Same thing down here. 2, negative 1. 2 times 2. 2 times 2. Who's with me? Thank you very much. I need everyone with me. I know you can answer this, right? Listen. You should listen with both ears, right? So, 2 times 2, we know it's 4. What's negative 1 times 2? All right, negative 2. Now, plot those new points, and you have your dilated figure. Should be bigger. Should be double twice as big. There you go. Here. Here. So, 2, 2, one point. That's A prime. Okay, that's what this little thing means, prime. Negative 2, negative 2. That's going to be B prime. 4, negative 2. It's going to be C prime. Okay, it makes a triangle that's twice as big. No, not there. There. Cool. So, everyone was able to draw the original and then graph the dilation. Twice as big. I multiplied all of my x's and y's by 2. So if I change that scale factor, you'll be able to multiply that and get that new shape, right? Okay. So for those of us who are not finishing tests, okay, we're going to do these notes. But they're easy to catch up on. So for those of y'all taking your test, don't rush, but you do need to finish today. So pseudo rush. Don't rush. But let's get it done. All right. So passing out the notes. We're going to knock out dilation notes. And then you'll have a dilation assignment. All right, what's for him? Okay, notes on dilation scale factor. Now, everyone's got this sheet. Now, dilation. Okay. By the way, we got to know how to say this word. Dilation is not dilation. Okay, it's not like you're dialing. Well, phones used to dial phones, I guess. But dilation is how you say it. It's a transformation of an object that produces an image that is the same shape. So I want you to underline that, please. Same shape, but what? The size is different. Okay? Same shape, different size, right? Now, if you remember, that's what we call similar. We did similar triangles this school year, even though it was technically last year, okay? And we're kind of taking some of those ideas with us this time around. By the way, since we're doing notes, I do want headphones out of our ears. That'd be great. If you're doing notes with me. Taking a test, okay, fine, whatever. Spins away. So, scale factor of a dilation is the number that describes the size change. Size change. Now, whenever we have two pictures, like look at this smiley face, right? The first one that you start at is called the pre-image. Okay, you start with a pre-image, and you end up with an image. The pre-image is what you start with. Multiply by your scale factor to get your image. That is this dilated image. Okay. Now, scale factor is represented by a letter. Off to the right, it tells you what that letter is, right? What's the letter for scale factor? K. It's off to the right here, right? So it says K stands for scale factor. That's weird because there is no K in the word scale factor, but it is what it is, right? And we already said no headphones, right? With me? So, scale factor is K. Now, to do today's work, you got to know something. Y'all ready for this? You need to know no. Y'all know no? Not yet. All right, check it out. Scale factor is what letter again? K, right? K equals what over what? New over old. New shape over old shape, right? So K equals N over O. Y'all know how to spell no? K-N-O-W. Now, the W's gone. So you got to know K-N-O. K equals N over O. Okay? Now, this is old, right? You probably learned this a long time ago. New over old is your scale factor. Cool? So, example 1. It says, what is the scale factor of dilation from pentagon 1 to pentagon 2? Now, think about this. If I'm going from 1 to 2, which one's the original? If I'm going from 1 to 2, which one's the original that I started at? 1, right? That's my old one. And I'm going to pentagon 2, put a little 2 there. Okay? If I'm going to pentagon 2, this is my new one. Put a little N there. Okay? Cool. So I know which one's new. I know which one's old. And I need to know K equals N over O. So let's rewrite this. K equals N over O. All right. Now, for N over O, does everyone see 8 and 5 are corresponding sides, right? And if they're corresponding, all I'm going to do is put the new one over the old one. Which one is new, 5 or 8? Now, we just labeled it. So the one that's new I have is 5, because that's the one I was going to. I ended up with 5 as my side length over the one I started with pentagon 1, which is 8. Okay? 5 over 8. You've got to know N over O. Okay? So, that's it for that one. Okay? Now, that seems simple, but it's deceptively simple because sometimes you might get mixed up which one's new and which one's old, and then it'll be wrong, right? It's got to be the right one over the right one. Now, second one. What's the scale factor from Medusa Blue? Pentagon 2, Pentagon 1. What changed? The order, right? So now, I'm going to scratch this out. Now it's going from 2 to 1. So now which one's new and which one's old? So if I'm starting here, this is my original. Put an O here. Going over here, that's my new one. Put an N here. So yeah, if they switch the order, just flip your fraction basically. That's all that's going to happen. Okay? So now my new over my old is going to be 8 over 5. Now it's getting bigger. 8 over 5 is bigger than 1. Okay? Is everyone understanding how to figure out scale factor? New over old, or new over original. You know what I mean? Now, number 4. If the scale factor is greater than 1, what do you think is going to happen to your picture? Bigger or smaller? Bigger, right? Bigger than 1, I'm going to make it bigger, right? So we can write bigger, but the math word we'd rather use is off to the right here. It's going to be a stretch, right? Stretch. Now, it says scale factors between 0, what? Between 0 and 1. Now, tell me, what's the number between 0 and 1? What's the decimal between 0 and 1? 0. What'd you say? 1.5? Okay. And what's a fraction between 0 and 1? That's not 1/2. Third, 1/4, either way. So if you see a number that's a decimal or a fraction between 0 and 1, that'll make it not bigger, but smaller, right? And we're going to say in math, the better word is shrink. Okay? So if it gets bigger, times the number bigger than 1, that's stretching it. Times the number smaller than 1, that's shrinking it. Really. Now, example 2, talk about dilation. Under a dilation, the picture shown at the right has been reduced in size. Reduced. Okay, that's my key word. It doesn't tell me which one's new. It doesn't tell me which one's old, but it does have this keyword reduce. Now you tell me, which way is it going if it's reducing? Is it going from left to right or right to left? So, what do you think? Yeah, you. Now, which one's getting smaller, left to right or right to left? Left to right. Okay, if I go from here that way, that's going to make it smaller, right? So that means which one's the original? What does it have to start at to end up smaller? Starts at big, ends up small. Original or old one is big, new one is smaller, okay? You have to infer all that. You got to know reduce means smaller, so it's going from big to small, so the big one's original and the small one's new, right? Really. Now, let's make a fraction. We know to find scale factor, k equals n over o. Because you got to know to know the answer, right? All right. Now, new one is what? So I got corresponding sides here. What's the new one? 12. And the old one is 48. So let's reduce that fraction. What is 12 divided by 48 reduced to? Show me. Okay, you can divide them both by 12, and it's going to be 1 over what? 1 over 4. Okay, so 1/4. Now, some people would get the answer 4 over 1 because they have it mixed up. They have it upside down, right? All right, so now, number 5. We good on example 2? Once you've found the scale factor, you can find the links to the sides of your shape by applying it. This is an alternative setting up of proportion. Okay, but you know what I'm going to do? I'm going to tell you just to find the proportion. Okay, so y'all remember finding proportions in similar triangles unit? Okay, now you can find the scale factor and then re-multiply it, which is fine. Let's see. If we're going from original to new, AB corresponds with which one of these sides? A prime, B prime. Okay, let's find the scale factor. New over old. Now, see these two are connected? Which one's new? Which one's n? 11.5 over, what's the original? 4.6. Now, we're going to actually divide these to get a number. 11.5 over 4.6. Okay, we get 2.5, 2.5. All right, so my scale factor, my K is 2.5. So if I want to find B prime, C prime, I'm going to have to multiply BC, which matches with 12, times my scale factor, okay? So let's take that 12 times the scale factor of 2.5. and I'm going to get, what is it, 30? 30. Okay? You can first find the scale factor, multiply the side you know, to get the one you don't know. Okay? Now, that's one way to do it. Okay? Now here's the other way I'd like for you to do it. This is the other way I taught you when we were doing similar triangles. Okay? Okay? Y'all remember when we connected two sides? We set up two fractions, and we cross multiplied and divided. Y'all remember we did that? Or butterfly method? Okay? So this is off to the side. This is the other way. Okay? So here's the other way I'm going to show you. You should be writing something down. Right? Let's do this. So 12 goes with x. Let's make that a fraction. 12 over x equals, and then 4.6 goes with 11.5. So can you set those equal, cross multiply and divide? We've done it before this school year. Okay, so let's do that. 12 times 11.5. 138 equals, and then 4.6 times x, 4.6x, and then we want to divide by 4.6. And what do you know? We get the same answer of 30. Divide by that coefficient, we get 30. So does everyone see there's two ways to do it? You can either find the scale factor and multiply, or set up two fractions, cross multiply and divide. Okay? I prefer setting up two fractions, okay? But there's more than one way to do it. Okay, you can flip it over. Let's do the back. Talk about graphing. Now, we did this on our warm-up. If you're going to do a dilation, okay, if you start with xy, you're just multiplying them both by k, which is the scale factor. So again, given a center of dilation, xy, you take that center of dilation and you multiply it by the scale factor k, both x and y. Okay. So example 1, I want you to graph all 3 points. Everybody, right now, on number, where we at? Example 1, on the back, graph A, B, and C. Okay, I want you to graph it right now. Can you graph 9, 6? Like for real. Can y'all graph 9, 6? 9 is the x value, 6 is the y value. Okay, let's do that right now. 9, 6, put a point there. Label that A. Okay, let's do B. Negative 6, 0. Negative 6 doesn't go up or down. That's my B. 6, negative 3. 6, negative 3. Put a C there. Now we don't have, sorry, I don't have a straight edge for you to do your best to draw straight lines between all 3 of those, right? So everyone's drawing the triangle A, B, and C. Come on, do it. Okay. Do your best triangle there, A, B, and C. Now, it says to dilate it by what scale factor? 1/3. Now, that means you're multiplying everything by 1/3. Now, y'all know that multiplying by 1/3 is the same thing as dividing by 3? Okay, so it's like dividing by 3. So we're going to take all these numbers and either multiply by 1/3 or divide by 3. So let's do that. I'm going to do it in blue. So 9, 6. 9 divided by 3 is 3. What's 6 divided by 3? 2. Good. That's my new A prime. Let's plot 3, 2. 1, 2, 3, 1, 2. This is my A prime. Do it with negative 6, 0. Negative 6 divided by 3 is negative 2. 0 stays 0. Divide it, it stays the same. Negative 2, 0. Put a b prime there. Okay, and then 6, negative 3 divided by 3 is 2, negative 1. You can put a c prime there. Once you divide all your numbers by 3, plot the points, you can connect them to make a dilated triangle. This is not a stretch, this is a shrink. Okay, 1/3 is the scale factor, shrunk it by a factor of 3. Okay. You're going to have to do that on your assignment. So do you know how I got those numbers? I multiplied by this scale factor, I got my new numbers, I graph them, and it looks the same shape but a different size. And then we have our last example. Okay, everyone staying with me? Wait, everyone with me? So, on example 2, let's scroll down. All right, what is the scale factor of dilation from ABCD to A prime, B prime, C prime, D prime? Now think about it. If I go from one to another, which one's the original? The first one, where you start, right? So this is my original, and I go to the new, right? So let's label this. Where am I going to put O? A, B, C, D is the smaller one, right? Put an O there. A prime, B prime, C prime, D prime, that's the bigger one. Put an N there. Now, do you see any numbers labeled on there? No numbers. But I know you can count horizontally or vertically, right? So why don't we do, first of all, K equals N over O. And let's pick the ABs, okay? So my original from here to here is AB. I could count that, right? So AB is my first one. And that's my new one. Sorry, let me back that up. Crazy. The new one is up here, right? A prime, B prime. That's my new one, right? So let's write that. A prime, B prime. And my old is from A to B, regular AB. So can you count from A prime to B prime? Let's do that. Here's A prime. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, A prime, B prime is 15 units long. So we're going to put 15 over, and let's count AB. Starting here, so we got 1, 2, 3, 4, 5, 6. 15 over 6. Can we reduce 15 over 6? What does 15 and 6 divide by? Not 6. 3. 15 divided by 3 is 5. 6 divided by 3 is 2. To go from the original small one to the big one, 5 over 2. That's my scale factor. Now I could do that all over again for letter B, but notice, what does it say? The only thing that changed is the order. This and this switched places. So guess what I'm going to do with this fraction right here? Flip it, okay? So if these were switched, then we're just going to flip that. So we're going to get 2 over 5, okay? Now you can show me your work on that one. That'd be fine, but if you know one and it just flips it, flip it, okay? Now that's the gist of the notes. Let me give you the assignment of dilations, and we'll work on that.